All right, today's goal is to help show you the need for the product rule. In fact, we're going to basically start from derivatives that you recognize or are able to do with the techniques you have already, and then show you the fact that it doesn't actually work in all cases. And so it necessitates the need for the product rule. To start with, we're going to do some basic examples. So we're going to kind of go through these quickly, and hopefully this will make sense to you. If I was to ask you for the derivative of x to the fourth, what would you say? 4x cubed, right? You drop the 4 down in front, it goes down a power, you get 4x cubed. Great. How about if I asked you for x cubed? Your statement, of course, would be 3x squared. What if I asked you for x to the seventh? What would you get? That would be 7x to the sixth. Make sense? Now, if I asked you, and I don't have it here, but let's look at x squared. What would be x squared? X squared would, of course, be 2x. How about cosine x? What is the derivative of cosine x? And we're going to use all these in just a minute. I'm kind of setting the stage up. Derivative of cosine, if you remember, is negative sine x, right? Good. Now let's come back to this one up here where it said find the derivative of x to the seventh. If I asked you to do x to the seventh, you'd expect to get 7x to the sixth. If we look at, okay, the fact that x cubed times x to the fourth equals x to the seventh, then shouldn't it mean then that if we use the idea that this would be, this one would be 3x squared, and this would be 4x cubed, your gut might be, hey, can I just multiply those derivatives and get the answer? And so you would say, okay, if we did, that would give me 12x to the fifth. So that's not the answer. Are there any other thoughts as to what we could do? Is there a way that maybe we could add them? Well, you might think you could add them, but they're not the same exponent. In other words, you can't actually combine those because they're not like terms. Well, and we understand that when you multiply those, 12x to the fifth is not the same thing, as the answer that we have here, 7x to the sixth. So that can't be right. It can't be that you can just multiply the derivatives. All right, keep that in mind. So as we look at this last example here, find the derivative of x squared cosine x. If you remember, this example here was x squared, and this was the derivative of cosine. So using that same idea, our gut is the derivative of this then would be negative 2x sine x, and it is not correct. So evidenced by the x cubed next to the seventh, we've got to figure out a way to deal with this. Again, back to that. So x cubed times x to the fourth, the derivative of that, as we said, is 3x squared times, right? And we'd have 4x cubed. And so our gut, again, would be to multiply that, but that is incorrect. Remember that it's 7x to the sixth. So the rule actually is quite different from what you're used to seeing. It isn't just taking the derivative of each of them separately. So how do we do this? How do we do the lovely product rule is what we call it. So here's the rule, okay? It is the first times the derivative of the second plus the second times the derivative of the first. In terms of f of x and g of x, let's say we have f of x times g of x, and I want its derivative. If I want the derivative of that, then what it would be is the first function stays the same times the derivative of the second plus the second function times the derivative of the first. Now let's come back to this example that's up here and see if it works. Our two functions are x cubed and x to the fourth. So what that would mean, so we'll deem this as f of x, and this would be g of x, or the first and the second. So the product rule says this: the first times the derivative of the second plus the second times the derivative of the first. And so what I have here is 4x to the 6 plus 3x to the 6. And sure enough, I get that 7x to the 6 as we expect right there. So now let's look at that x squared cosine x question that you had in the previous slide. Okay, the first function is x squared, so it would be first times the derivative of the second plus the second times the derivative of the first. And so to finish this, we would have negative x squared sine x plus 2x cosine x. Now let's try these. I just did that first one there, so let's do the next one. 5 cosine x. You can treat this like you always have because this is a constant, but just to show you the product rule works even for this, let me show you how this works. The first times the derivative of the second plus the second times the derivative, what is the derivative of 5? Times 0. And so what's going to happen? This term goes away. So again, when that constant's out in front, it really is finding the derivative of just that cosine and tacking that 5 on at the end, or multiplying by that 5. All right, let's try this one. The first times the derivative of the second. What's the derivative of natural log of x? You might have to look back in your notes because this is part of those unique derivatives that we need to make sure we know. But the derivative of natural log is 1 over x plus the second times the derivative of the first. And so just to simplify this, again, notice the x's would divide out, so you'd have 5 plus 5 natural log of x. Let me just note to you that it is possible that you might see it like this as well, with the 5 factored out. All right. Let's look at the next one. 5 times the natural log of x, again, the derivative. See how this is a constant. The difference between the one right before it is that the one right before it had an x with that 5. And so that's treated slightly different. This one we really could just say 5 times 1 over x and be done with it. But just to prove my point, I'll do it the other way. The first times the derivative of the second plus the second times the derivative of the first. And again, that 0 term would cancel out, showing you that you could have just left the constant, so it would have been 5 over x. Okay, last example here. So I had e to the x times sine x. So why don't you go ahead and try this one. I know it's slightly different than the ones you've done already, but go ahead and take a few seconds to do that. To do this question again, in case you didn't pause, but hopefully at this point you've gotten at least something. You want to do the first times the derivative of the second plus the second times the derivative of the first. I will tell you that frequently when you're talking about e to the x, you will see that that is factored out in your answers. And so another option for this answer would be e to the x factored out, cosine x plus sine x. Okay, so that's how you deal with the product rule. First times the derivative of the second plus the second times the derivative of the first. And we'll be working on this in class quite a bit. You'll see this being applied over and over. And then tomorrow you're going to hear about the quotient rule. What happens when they're dividing? And we've already run into a few of those where we've had to simplify them. But what happens if you can't simplify? That's what we'll be dealing with in tomorrow's video.